Welcome once again to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. And we continue to explain chapter number 6 of Pure Mathematics 3, Differentiation. And we are going to look at example number 3 in this particular video. This is example 3, which talks of a curve has equation y is equals to a half x minus cosine 2x. Find the stationary point of the curve. We could be having point or points. So let's put that in plural, points of the curve in the interval 0 to pi. And we all know that at the stationary point, the dy dx is equals to 0. So before we do anything, we must be prepared to differentiate the function of the curve given, and you have dy dx is equals to a half, of course a half minus, this is cosine 2x, which is minus 2 sine 2x. Of course, you can confirm that from the previous videos, which already gives us a half a half plus 2 sine 2x. And at that point, it is very important to note that when we are saying a half plus 2 sine 2x, it is now this derivative which is equals to 0 because it is at the turning point, a stationary point. You can call it stationary point or turning point. It could be maxima or minima. It doesn't really matter. So it follows that a half plus 2, the sine of 2x is equals to 0. And if this is true, 2 sine of 2x is equals to minus a half. And if this is true, the sine of 2x is equals to, divide by 2 both sides, negative a quarter. And as you know, of course, we must talk about where is the sign negative. According to all science teachers complaining, the sign is negative here and in that quadrant. So which angle whose sign is a quarter? And we realize that 0.25 equals to the shift sign answer is 0.253. This is 0.253 and this is 0.253. So at the end of the day, because the range is from 0 to pi, that means the range for 2x is going to be 0 to 2 pi. So we will be allowed to go around the whole circle. And of course, we are going to say 2x is equals to, you can say pi plus, because this is pi going clockwise, plus 0.253, which is plus pi, which is 3.39, which is 3.39, or 2x can also be equals to 2 pi because of the whole complete circle, minus or less 2 pi minus 0.253, which is going to be minus 0.253, which is 6.03. And because this is just 2 pi, or rather 2x, we are going to talk about x is a half of this, which is 1.7, around 1.7. Let's confirm that together. 3.39 divided by 2 is 1.69, which is 1.7 to 1 decimal place. And of course 6.03 divided by 2, which is going to be, or x is equals to 3.015. Having said that, or we can talk about 15 or 3.02 for that matter. Having said that, we are supposed to give the coordinates of the stationary point. So we have to substitute this in the original function and say when x is equals to 1.7, y is supposed to be equals to a half 1.7 minus the cosine of 2x, which is 2 times this. Okay, 2 times 1.7, and that one can easily be calculated. A half 0.5 times 1.7 minus, of course, minus the cosine of, into bracket, 2 times 1.7 closing bracket. You will realize that this is 1.82. This is 1.82. That is a perfect value of y. So when x is now 3.02, y happens to be a half 3.02 or minus the cosine of 2 times 3.02. Again, using the calculator, you realize that y is simply going to be 0.539. Y is going to be, okay, we can just do it 0.5, or rather 0.5 times 3.02 equals to minus the cosine of into bracket 2 times 3.02 close bracket, and you'll find this is something to do with 0.54. 0.539 is equals to 0.539. So you will agree with me that the stationary point has, or rather points, they have coordinates, one which is given by 1.7, 1.82, and another one 3.02, 0.539, and those are the coordinates of the stationary point. As far as now is concerned, we still don't know which one is a maximum or which one is a minimum. We have to know how it behaves to the left and to the right to declare which one is the minimum and which one is the maximum. Or even better still, we can go for the second derivative, and we can know using the second derivative which one is maxima and which one is minima. As per for now, yes, that is our task. We are supposed to establish the stationary points of example 3, and we have done it. Again, visit my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho, and subscribe and share widely, and let us reason together. Thank you.